Hello everyone. Class 12th, topic name preparation of haloalkanes from alkanes and halogen. Alkanes we all know, those hydrocarbons in which carbons have single bond with each other, and halogens fluorine, chlorine, bromine and iodine. These are halogens. So in this preparation method we are going to react a particular alkane with given halogens. Halogens in this reaction I will represent with X2. Now first of all, let's understand in a simple manner what is happening over here. In these reactions, substitution of hydrogen by X is happening. Like suppose this alkane I have and I'm going to react with X2. So any hydrogen, let's take this hydrogen. This hydrogen will be substituted by 1X and the rest hydrogens will remain as it is, no change here. And what will be the side product? H is replaced by X, 1X is available here, 2X are there, so that will combine with this hydrogen, so side product will be HX. Now let's understand few important points over there. First of all, these reactions are happening with free radical mechanism. Free radical mechanisms we have understood in previous video also. They are three-step mechanisms: chain initiation, chain propagation and chain termination. Now first you need to understand the degrees of hydrogen in alkane. Suppose I have written this alkane. Let's start with this carbon. This carbon is directly connected to a single carbon, so it's 1 degree. So the hydrogens which are attached on it, they are also known as 1 degree hydrogen. This carbon itself is attached directly to 3 carbons, so it is 3 degree carbon, and the hydrogen which is attached to it will be 3 degree. Similarly, this carbon is 1 degree and hydrogens attached to it is 1 degree. In a same pattern, these two hydrogens will be 2 degree and these 3 hydrogens will be 1 degree. Now, substitution order. 1 degree hydrogens are least substituted hydrogens. Then 2 degree hydrogens rate of substitution will be more than 1 degree hydrogen. And 3 degree hydrogens are mostly substituted if we compare among all. Reason. As I already told you, these reactions means these alkane and halogens are going to react with each other through free radical mechanism. Okay. And in free radical mechanism, free radicals are generated. Suppose this hydrogen is going to be substituted by halogen. So this carbon-hydrogen bond will break. This bond is made up of 2 electrons, and in free radical mechanism always equally electron sharing is there. So this hydrogen will get its electron and it will leave its carbon. A carbon free radical will generate. Now please check what will be the degree of this carbon free radical. It is 1 degree carbon free radical. Means if hydrogen of 1 degree carbon will be substituted by halogen, during the course of the reaction, during the mechanism of the reaction, 1 degree carbon free radical will generate. On a same pattern, if I substitute this hydrogen from halogen, 3 degree carbon free radical will generate. If I substitute this hydrogen from a halogen by a halogen, 2 degree carbon free radical will generate. In 11th class, we have done a concept, stability order of carbon free radicals. If I talk about these 3 carbon free radicals, 1 degree, 2 degree, 3 degree, so 1 degree carbon free radical are least stable. 2 degree carbon free radicals are more stable than 1 degree carbon free radical. And 3 degree carbon free radicals are most stable among all. Means if we are going to show substitution reaction, means hydrogen we are going to replace by halogen, so which hydrogen will be preferred by reaction? This. Because during substitution of this hydrogen by X, 3 degree carbon free radical will generate during reaction. And 3 degree carbon free radical is most stable carbon free radical among all. And we know reactions always prefer stable paths. They don't prefer less stable paths. If they will if suppose reaction is going to substitute this hydrogen, the 1 degree carbon free radical will generate, which is a less stable path for the reaction. Here reaction have an option. What option? 3 type of free radicals can be formed over here. 1 degree carbon free radical, 2 degree carbon free radical, 3 degree carbon free radical. So the reaction will prefer most stable path, most stable free radical. That will be generated through substitution of this hydrogen. Now, if I am going to react it with X2, so 3 products are possible over here. Suppose I am substituting this hydrogen, 1 degree hydrogen. So what will be the product? Rest I am writing in a short way. So please understand it. X I have joined here. Suppose this hydrogen is getting substituted. The product will be this one. Suppose this hydrogen, let's substitute this hydrogen. This is also 2 degree hydrogen. So we will get this product. Similar product we can generate by substituting this hydrogen also. But I have made this to understand the concept. Now, out of these 3 products, which will be the major product? The major product will be this one, which is generated through substitution of 3 degree hydrogen. This will be the major product. Means suppose we have 100 particles of final product. Out of 100 particles, 95 particles will be of this product, followed by this, and the least number of particles will be of this product. This is major product because it was generated due to substitution of 3 degree hydrogen. When 3 degree hydrogens was getting substituted, 3 degree carbon free radical was generated during mechanism, which make this hydrogen to be substituted very easily, because the 3 degree carbon free radicals are most stable carbon free radicals among all, followed by 2 degree carbons, which is this, and least 1 degree carbon free radicals will be generated by the substitution of this hydrogen. So that's why reaction is preferring very less substitution of these type of hydrogens, 1 degree hydrogens. So I hope you got the topic. In next videos, we will understand another part or another points related to preparation of haloalkanes from halogens and alkanes. Thank you very much for watching the video.